Saxon Advanced Mathematics, lesson 24. We're adding to our study of functions. I made a list last time about the different kinds of functions. We've had linear functions, and then we talked about reciprocal functions, right? A linear function goes like that, and a reciprocal function does a weird thing where it goes like that and like that, right? Those were kind of weird. We had absolute value. They're very sharp. They make a V. That's my flying geese formation. And then we talked about exponentials. And they go either like that or like that, depending on whether the base is greater than 1 or less than 1. And we haven't looked at the pictures yet, but trig functions fit this same definition. They can be graphed. We haven't done that yet. We're going to fairly soon. They can be graphed, and they have a super cool shape. At least some of them do. And we're going to talk a lot about the shapes of trig functions as we go. We're not ready to do that yet. We're not ready to throw this picture into the mix. What we're going to do is just still manipulate the numbers of trig functions without looking at the pattern that it makes. All right, so we're going to look at problems. This is to come. I think it's between, it's right around Thanksgiving, I think, that we'll break into these. So it's coming soon. 24.1. This is the kind of problem that we're going to do today. It says evaluate cosine of 60 degrees plus the sine of 45 degrees. Okay. Now, the first thing I want you to notice is these are familiar angles, aren't they? They are our friendly reference triangles. This would be part of a 30, 60, 90. This would be the 44, 45, 90. So we can calculate these without having to refer to our calculators. That's good news. So what I'm going to do is I'm going to start over here, and I'm going to calculate the cosine of 60 degrees just by using the triangle. Now let's see. I normally draw the triangle like this, so I'm going to draw it the way I always draw it. The 30s here, the 60s here, that's the 90. It used to be like this, and I chopped it. So this side is 1, this is 2, that makes this square root of 3. But I want the cosine of 60 degrees, so I'm standing up here, right? Cosine is equal to a hold. Oscar had a hold over Arthur. So from up here, my adjacent side is 1, and the hypotenuse is 2. So the cosine of 60 degrees equals 1/2. Okay. Now let's do the sine of 45 degrees. Okay, that triangle. Super easy to draw, right? This is 45. This is 45. It's 1, 1, square root of 2. If you haven't memorized these numbers yet, work on that. We're gonna be using them a ton. So make sure you can draw these triangles fairly quickly. All right, so now we're gonna do the same thing. The sine is, let's see, Oscar had, right? And so if we're standing down here, we'll put ourselves in. If we're standing down here, the opposite is 1, and the hypotenuse is square root of 2. Okay? You may notice that for the 45, 45 triangle, the cosine and the sine are the same, right? Because the only difference between cosine and sine is one uses opposite, the other uses adjacent. And in this triangle, they're both 1. So yeah, that's exactly right. Okay, are you ready? In order to finish our problem, all we have to do is add 1/2 plus 1 over the square root of 2. Allow me to do that on the next page. it's 1/2 plus 1 over the square root of 2. We know that needs to be rationalized. That's right, but it also needs to be rationalized so that we can have matching denominators. So we'll multiply this guy accordingly, and we'll get 1/2 plus square root of 2 over 2, because that makes 2 now. And then that can be written as 1 plus the square root of 2 over 2. That's the answer to our problem. That is the cosine of 60 degrees plus the sine of 45 degrees. What does it mean, and why would you want to use it? These are questions that will be answered in future classes, in calculus, and in, engineering type classes. We're not going to deal with that. We're just going to help you get used to moving the numbers and being comfortable with the calculations so that later, when somebody lays that theoretical information on you, it will not freak you out. You'll be comfortable enough with these calculations that you'll be able to see kind of the deeper layers. That's the way John teaches, and I really think it's wonderful. He says, let's get used to just moving the numbers around and how to do that, and then later we'll get into the theory. And I really like that. Okay, let's do another one like this, except I'm gonna sneeze, hang on. Excuse me. Example 24.2. Very similar problem. We're asked to add the tangent of 30 degrees plus the cosine of 45 degrees. I want to show you how I would set this up for maximum simplicity in your homework. Tangent of 30 degrees plus cosine of 45 degrees. I wrote that across the whole line because I'm going to work down on both sides. So that's our original problem. I'm separating the two sides. This one, I need the 30, 60, 90 triangle. And for now, I want you to keep drawing these triangles over and over as you need to for each problem. We're not going to do that forever. I promise you that quite soon we're going to take a shortcut that makes it so we don't have to keep drawing these. But for now, I want you to keep drawing them so that they'll get put into your memory. We're at 30 degrees, so we're standing down here. And we want the tangent of 30 degrees. Tangent is over Arthur, right? So that would be the opposite side over the adjacent side. All right, there we have that. Now we're ready to do this little puppy dog. 45, 45, 90 triangle, 1, 1, square root of 2. We're standing at 45 degrees. They're all the same on this one, right? And we want the cosine of 45 degrees. That would be equal to, cosine is A hold. Oscar had A hold over Arthur. And that would be, the adjacent is 1, the hypotenuse is square root of 2. Again, you're thinking cosine and sine are the same. That's right. And now all I have to do is add them together. 1 over the square root of 3, that's the tangent of 30 degrees. 1 plus 1 over the square root of 2 is cosine of 45 degrees. All right, we have a little bit of algebra to do so that we can solve this, right? First, we'll have to multiply in order to rationalize the denominators. That's a 2. And we'll get square root of 3 over 3 plus square root of 2 over 2. Okay, that looks good. Now we just have to make the denominators match so that we can add them. So we'll multiply. Here, I'm going to move it over. Right? We'll multiply this one to get an LCM of 6. Right? And so we'll have 2 times the square root of 3 plus 3 times the square root of 2 all over 6. That's our final answer. That is the tangent of 30 degrees plus the cosine of 45 degrees. Do we know why we would want to find that? Do we know what it's used, what it's good for? No. Do we know how to do it? Yeah, that's fairly reasonable, right? Now we're going to make it just, we're just going to add one more little complicating factor. (23.3). This time we're adding tangent of 45 degrees. Okay, that seems very doable. Plus 2 times the tangent of 30 degrees. What's this? What's that number in front of it? That looks weird. Yes, it does, but don't worry. I'll show you how to handle it. It's easy. Okay, so we're going to make our chart so we can keep the two sides separate. Tangent of 45 degrees. I draw the triangle once again. 1 square root of 2. I'm not even going to put the angles in this time. I'm keeping it simple. Tangent equals over Arthur equals 1 over 1. This time we need the other triangle. 1, 2, square root of 3. We're at the 30 degrees, so we're standing here. This is the 30, 60, 90 triangle is where we have to be sure we're oriented properly. 45, 45 is the same, so it doesn't, the angles are the same, so it doesn't matter. All right, tangent equals over Arthur, and so it equals 1 over the square root of 3. And now you can see it's easy enough just to rationalize this right away so that we don't have those crazy square roots hanging out. Now, how do we finish this off? Simple. We take the tangent of 45 degrees, which is 1, and we add 2 times the tangent of 30 degrees. Tangent of 30 degrees is this, so we just multiply it by 2. We don't really need the parentheses, but I just wanted you to see that I'm multiplying 2 times the tangent of 30 degrees. That's all there is to it. We just multiply that number by the answer of this when we get it. In order to add them, I'm going to have to change this to having a denominator of 3. And so my final answer, I'll go this way, is 3 plus 2 times the square root of 3 all over 3. And that's the right answer. Okay, so when we have a coefficient in front of the trig function, don't worry, just find the trig function and then just multiply the answer. And I do believe we have one, oh no, that's the end of this type of problem. Now we're going to talk about I'm finding another problem. Oh, yeah, there's one more problem, sorry. Example 24.2. There's one, I'm sorry. It should be 4. All right, I thought we were switching topics, but we still have one more problem. My bad, I was confused. Ready? Evaluate square root of 6 times the sine of 30 degrees plus 1 over square root of 2 times the tangent of 60 degrees. All right? We learned our lesson last time. We don't let these coefficients freak us out. We're going to stay focused on calculating the trig functions. And then once we turn these into fractions, we'll just multiply by these random coefficients. So, once again, give ourselves some separate workspaces here. This is the 30, 60, 90 triangle. 1, 2, square root of 3. Sine is Oscar had. We're standing here. Opposite is 1. Hypotenuse is square root of 3. 45, 40. Oh no, it's not this one, sorry. It's this one again. 1, 2, square root of 3. But this time we're at the 60-degree angle. We're up here, right? So when we go to find the tangent, which is over Arthur, we know we want the opposite from up here, which is the square root of 3, and then we want the adjacent, which is 1. Okay, now we're ready to multiply. Let's go ahead and multiply still in our separate compartments here, right? It's the square root of 6 times oh, I wrote the wrong thing here. This should be a 2, shouldn't it? It should be the hypotenuse. Sorry. Square root of 6 times 1/2. The square root of 6 is random. That was just given to us. So this becomes the square root of 6 over 2. And here we take the tangent and we multiply it times 1 over the square root of 2. That equals the square root of 3 over the square root of 2. We need to rationalize this. And so this becomes square root of 6. These are both pigs, right? So they go together over just plain 2. And now we're ready to add. This whole thing is this, plus this whole thing is that, and it equals 2 square root of 6's over 2. And then look, we can cancel that. So this whole thing adds up to the square root of 6 as our final answer. Right? This was kind of tricky. We're adding, so we don't add together the pigs. We just say, oh, we have 2 of these now, and then it's over 2 because that's the denominator, and then we can cancel that. Cool, right? Okay, so again, don't let these coefficients freak you out. They're just there to be combined at the end. All right, now we're ready for the second part of our topic, which is called combining functions. And these functions, we're not really worried about what shape they make. We're not graphing them. We're just looking at the numbers and how we can combine things. We're using functional notation for these, just because it helps clarify things, and I'll show you what I mean when we go. Let's do example 24.5. If f of x equals log of x. Ooh, did your blood just run cold when I wrote logarithms? Sounds so scary, but don't worry. Logarithms are a kind of function, but we're not going to do anything complicated with them today. We're doing something super simple. And then we're told there's this another function called the g of x, and that looks like this. What we're supposed to do is say, okay, so there's 2 separate functions here. We used functional notation because we wanted to give them names, because that's super helpful to say this is the f function, this is the g function. What John wants us to do he wants us to find something called, what I call this is the g eats f function of x. We're combining these 2 functions, and what this notation tells us is that we're supposed to put the f inside of the g function. Now, that's tricky to remember, and that's why I use this little cheat. I call this symbol the eats function. G eats F. That helps me remember which one goes inside of which. So what I do is I take this expression. So when I want to find G eats F, I take the G, I put a blank, and then I write this in here. Do you see how the G function is eating the F? And that is our final answer. That's why the log thing doesn't have to scare you, because we're not really doing anything with it. We're just letting the G function eat the F function. Let's try another one, and we'll see what it needs. Oh, this one's got lots of parts. Here are our two functions. Ready? F of x equals x plus 2. Oh, that looks so much more manageable, right? And g of x equals x squared plus 3. Now we're going to combine them in 4 different ways. We did the most complicated combination right there. Now we're going to experiment with the simpler ones. So for the first part, we're supposed to find the f plus g of x. So what we're supposed to do is we're supposed to add these two functions. Oh, I'm sorry, not of x, of 6. So what John's asking us to do is, we can look at it 2 ways. One thing he could be saying is put these two functions together and then find out what happens if you plug 6 in for the x's of the combined function. The other way we can do it, and we're going to do it both ways, just so you know. The other way we can do it is say solve this one for 6, solve this one for 6, and then add them together. Okay, so the first approach is to find the f of 6 and the g of 6, then add them. Okay, so let's see. The f of 6 would be equal to 6 plus 2, which is equal to 8. And the g of 6 equals 6 squared plus 3, which is 39, right? This is 36 plus 3 is 39. And then the f plus g of 6 would be equal to 8 plus 39, which is 47. So that would be our final answer for the f of g of 6, the f plus g of 6. And we did that by solving each of these separately for 6 and then adding the total. Now the other way that we can solve this is to say, let's actually combine the functions. I'm going to do that on the next page. And I'm just going to copy my functions over again. The f of x equals x plus 2, and the g of x equals x squared plus 3. I can calculate, so this is my second one, is to add the f of x and g of x then solve for 6. Scribble that out. Okay, so my first approach we did here, and my second approach I'm going to do here. So what we do is we'd say, okay, the f plus g of x would be x plus 2 plus x squared plus 3. And we can simplify that. The f plus g of x equals, let's see, let's put them in order, x squared plus x plus 5, right? Now we can find the f plus g of 6 by substituting 6 in to that combined function. All right, and that would be 36 plus 6 plus 5, which equals 47. And we got the very same answer as we did the other way. Now, which way is better? Well, I would say this. If you're only having to make one calculation, if you're only plugging one value in, like here we were just asked to do 6, it's usually easier just to run them through separately and add the total like we did first. But if you're going to be using multiple calculations of this combined function, if you want to plug in 6 and then you want to plug in 27 and then you want to plug in minus 9 over 14, then it makes sense to just go ahead and combine the function so that you can use it over and over again. In your homework, I want you to try it both ways. I want you to mix it up so that you feel comfortable doing it either way. Okay, that was all just experimenting with adding the two functions together. Now, in part B, we're going to practice subtracting one function from another. Now, here's the cool thing. To do this the first way, where we solve them separately and then subtract them in the end, we've already done most of the work because we already figured out that the f of x equals 8 and the g, or of 6 rather, and the g of 6 equals 39. Remember, we figured that out back here. 8 and 39. Last time we added them together, but this time we can just subtract. We can use those values to get a big jump on our problem. So the f minus g of 6 equals 8 minus 39, which equals negative 31. And that's correct. But we can also try it the other way, and that is where we actually combine the functions so that f minus g of x, without making it specific to 6, would be x plus 2 minus, and then we'll put the whole function in here, x squared plus 3, because we're subtracting all of that. So that would be x plus 2 minus x squared minus 3. So our f minus g of x would be minus x squared plus x minus 1. I'm just cleaning that up, right? Putting it in order and combining like terms. And so then our f minus g of 6 is equal to minus 6 squared plus 6 minus 1. Which is I'll do it over here. I don't want to turn the page. Minus 36 minus 1 more takes us to minus 37, and then plus 6 gets us to minus 31. And that's the same answer. Okay? In this case, man, we can see option 1 was way faster, wasn't it? Option 2 created a lot of extra work for us. Good to know. Okay, let's try one more. No, there's actually 2 more to this. In this case, C, we're multiplying the two functions. And again, this is really easy if we just take the values that we've already calculated, right? We know that to do it the first way, the f of 6 is 8. The g of 6 is 39. We multiply them together. It's just doing 39 times 8, that's 72. 24, 31. That's way easier. But we can do it the long way of actually combining the functions by taking x plus 2 and x squared minus 3. No, it's plus 3, isn't it? Yeah, it's plus 3. And we multiply them doing the dance. X cubed plus 2x squared plus 3x plus 6. That is the f times g of x. And so we can calculate the f times g of 6 by plugging 6 into that big beast. Make sense? 6 times 3. That's 36 times 6. Right? Because that's 6 squared, and then we do one more. 216 plus 36 times 2 is 72, plus 18 plus 6. That's the f times g of 6. And that all adds up to 312. Same answer. Okay? So again, sometimes it works out that the two approaches are roughly the same amount of work. Sometimes the second one gets to be a pain. D handles division. And in this case, for the first approach, we already know the f of 6 and the g of 6, so the f over g of 6 equals 8 over 39. That's the correct answer. And if we want to do it the long way, then we would take the f function, which is x plus 2, and we put that over x squared plus 3. And then we fill in the 6. Whoops, squared should be on the outside. Right? We combined the function. This is the fg of x, and then this is the fg of 6, and we get 8 over 39. Same way, okay? So what I want you to take away is that both of these approaches give the same result. Both of these approaches are fairly straightforward and simple. Depending on the context that you were using this calculation in a bigger problem, one might make more sense than the other. One approach might make more sense than the other. For homework problems, the first approach is usually easier because once you calculate the f and the g, you can use them over for the same number. But I want you to practice some of both, all right? Yeah, we're done. The more challenging part of this subset of our lesson, this combining functions bit, is this first part and remembering how to do this one where G eats F, right? Remember that I just see a Pac-Man. I just see him gobbling it up, right? And so the F is going into the G. This is the harder one to understand. Those other 4 that we did with the adding, subtracting, multiplying, and dividing, those are pretty straightforward, and it's just a question of cranking through the calculations. This is the one that can really confuse you if you don't remember how that works. And that's what I always say is G eats F, because it helps me remember exactly what to do. Lesson 24, yay! Guess what? It's done. You knew that. Goodbye.